Hello and thanks for watching Best Maths Tutors. We're continuing to go through the Edexcel 2018 A-Level Paper 1, and we're going to look at question 7, which is a question on definite integration. And obviously we'd love it if you would subscribe to our channel so you can see more of our maths videos. So in this case, what we're given is that K is, this Z plus means that it's a positive integer. So we're given that K is a positive integer, and we've got to show that this integral between the limits of k and 3k is independent of k. So that's our first part. And then in the second part, we've got to show that a slightly different integral, this time between the limits of k and 2k, is this time inversely proportional to k. So I'm going to look at the first part, and what we can see is we've got the integral of a fraction. So 3k and k are our limits, and the bottom of the fraction is 3x minus k. And there's a very useful way of integrating this, which is that if the top is the integral, is the differential of the bottom, then the result is that it's the natural logarithm of the bottom of the fraction. So I'll just try and write that in a sort of a formula format. So we've got a function on the bottom, f of x, and the top of the fraction is the derivative of the bottom of the fraction. If this is what we've got, then the result of that would be that it's the natural log of the bottom of the fraction. And if it was an indefinite integral, I'd obviously have to add a constant on there. Because we've got a definite integral, then it wouldn't need a constant add-in because we'd be working it out between limits. So we can see by looking at the bottom of this fraction that the top is nearly the differential of the bottom line. In fact, if we were to differentiate the bottom line there, so if we were to differentiate 3x minus k with respect to x, then we would actually just get 3 because k is a constant there. So if we could make the top of this fraction here, we'll make that equal to 3, then the top of the fraction would be the differential of the bottom. And what I can do is I could factorize or take out the 2 to the front since it's a constant. And actually, if I put a 3 on the bottom, I'd have to then have 3k as k is my limits. I'd have to have a 3 on the top of the fraction so that the overall value of the integral was the same as before. So we've now manipulated this so that the top of the fraction is the differential of the bottom. And that's great now, because what that means is we can actually say it's 2/3 and the integral will be the natural log of 3x minus k. I just need to put these limits on now. So the limits are between k and 3k. So I'm going to rewrite that. I'm going to just keep 2/3 at the front. Open up a bracket, and inside the bracket it's going to be, first of all, substituting in the 3k. So we get log of 3 times the 3k, so substituting in for x, minus k, and then subtracting from that the result of substituting in k now into it, so the lower limit. So if we do that, we'd have log of, this time, 3 times k minus k. So substituting in the value of x equals k into that. So I just need to tidy this up a little bit. So I've got 2/3 at the front. 3 times 3k is 9k, and then if I take away the k from it, I'm going to get 8k. So I've got log of 8k, and then I'm going to subtract from it the log of 3k, take away k, is going to be 2k, and so that's going to be 2k there. Okay, so what I'm next going to do is use the log rule for if I'm doing subtraction. So if I've got, the rule I'm going to use is that I've got log of A minus log of B, then that's equal to the log of A over B. So we're going to use that here, and so what we'll end up with is 2/3 of the log of 8k and then over 2k, which simplifies because I can cancel the k's there and divide the 8 by the 2, so that will give me 2/3 of natural log of 4, which we can see, since it doesn't include k, is independent of k. What we've now got to show is that the integral here, we do this integration, is now inversely proportional to k. So we'd expect our answer to end up being something like some constant over k, for example. So we could see that whatever k is, the answer would be inversely proportional to it. So I'm first of all just going to rewrite this, and I'm going to take what's in the denominator there and change the power to a negative one, so I can put the 2x minus k into the numerator. So that's going to be equal to, with the same limits, that's going to be 2, and then 2x minus k to the minus 2 dx. Now what we've got here is inside the bracket here is a linear function of x. So when we've got a linear function and we're trying to integrate it, what we can do is we can integrate the bracket as we would do normally. So if we've got minus 2, imagine that was not a bracket but an x to the power minus 2 is integrated. That would integrate to being to the minus 1, but then we'd have to divide by the minus 1. So in fact, dividing by minus 1 would mean that that would equal whatever's inside the brackets to the minus 1, and then taking a minus to the front there. But also, what we then have to do is divide by the derivative of what's inside the brackets. So we differentiate 2x minus k and divide by that. So then we divide by the differential of what's inside the bracket. So if we were to do that, we can see that inside the bracket, I'll just move this up a little. Inside the bracket, what we've got is 2x minus k, and if we were to differentiate that, so find d by dx of that, then we just get 2. So I'm going to integrate overall, then what I'm going to do is I'm going to integrate this as usual, so as the bracket there, as I described, and then I'm going to divide the result by 2. So if I do that, then what I will get with going to the square brackets, we'll have the 2, and then the bracket itself becomes to the minus 1, and overall we're going to get a minus as well, because the bracket we was dividing by negative 1 there. And then I'm going to divide the whole lot by 2, which is the differential of what's inside the bracket. And now the limits are still k and 2k. So we can see that the 2's will cancel, and I'm going to take the minus out to the front at the moment. So I'm going to have minus and then 2x minus k to the minus 1, and then between those limits. And actually, I might as well then deal with the minus 1 now and put this back into a fraction, so I'm going to put that back into the denominator of a fraction. So what I'll get here is 1 over 2x minus k, and then that's now still with those limits. If I then substitute the limits in, minus at the front, and I'm going to have 1 over 2 times 2k minus the k, the upper limit there, and then that's going to be minus 1 over 2, this time the lower limit is k minus k, and so put the equals there we go. So that's now going to tidy up to being inside the bracket minus, that gives me 4k minus k, which is 3k, and in the second one we've got 1 over 2k minus k, which is 1 over k, and so to do that we need to make sure we've got the same denominators, so minus 1 over 3k, so multiply top and bottom of the fraction by 3 will give me 3 over 3k. We can see that that's now going to be minus, and inside the bracket I'm going to have minus 2 over 3k. Deal with the minus signs there, minus minus is a plus, so that's 2 over 3k, which we can say that is proportional to 1 over k. And we've done it. So we've shown that it is, as was required at the beginning of that, it's inversely proportional to k. So I hope that's been helpful to you, and if it has, please like our video and subscribe to our channel to see more of our videos. Thanks for watching.